First of all, I want to thank the organizers for inviting me to share my thoughts on visualizing ecosystems and also participating in this exciting colloquium. I had a pleasure of meeting many of you already and discussing some of the challenges that we face in modeling and visualization. And I'll be talking to you about today is how we actually visualize complex systems, complex economic, socio-technical systems, and I'll be focusing on ecosystems today. One thing I want to do is that I've been doing this work actually for a long time, and I think the tools have really evolved, as well as the data, as well as the users that are actually consuming these solutions as well. They're getting more sophisticated and are having much more input in what they really want to see, given that they have more familiarity with the tools. But what I want to do is I want to step back and reflect back on what I've done in the past, and then also talk about some of the things that I'm doing moving forward. So a study that I did, can't believe it's been almost over a decade ago when I started collecting the data. When Jeff mentioned the smartphone, I think that was a wonderful context to study converging ecosystems. And so what I studied here are the different segments that contributed to the mobile ecosystem, and I identified 14 or so. And my goal was to identify companies that operate in each of these segments and how they collaborate, coordinate activities to deliver products and services. And at that time, I leveraged a data source offered by Thomson Reuters, SDC Platinum, which looked at alliances, which captures supply chain, R&D relationships, marketing, and so on. And I identified roughly 7,000 companies, about 18,000 relationships. Now, what's striking here is I'm only showing you sort of the core of that particular analysis. And what you're seeing is the yellow dots represent companies or segments that were existent. They were called the incumbents. And the blue dots were companies that were just entering the mobile ecosystem space. And what's kind of interesting to see here is some of the usual players are at the center. Cisco, Microsoft, IBM, Qualcomm, Nokia. And then you're also noticing a couple players like Google and Apple that were just entering at that time. And they're sort of slowly getting closer to the center. But you're also seeing a separation of the two clusters a little bit, which you're seeing that the incumbents are really highly collaborating with each other. And there are some connections among the emergent or entering players as well. And some were across those two different segments. Now, what we did do is we said, okay, what if we took that to a slightly higher level? So rather looking at the inter-firm linkages, we're looking at the inter-segment linkages now. And it was this interesting structure that emerged out of this as well, where you're seeing this trapezoid between silicon vendors, device manufacturers, network infrastructure providers, and mobile network operators, sort of the core of that. Pretty strong ties between application and software providers and platform providers. And then sort of this other part of the system as well. And then if you let math and graph theory really do its talking here, I didn't size the nodes by any measures, but if you did that, something really interesting emerged, which was that platform providers, if I remove that node from the graph itself, it would disconnect what's entering versus what's incumbent already inside. And if you look back at what happened in 2007 and 2008, was that there was a big platform war brewing, right? iOS and Android and other platform providers are competing against each other in that space. Jeff asked whether if he had a tool in 1995 to predict forward, I would say if this data existed in 1995, maybe we would have been able to see that platform providers are going to play a critical role in a lot of these technology ecosystems. And my data really showed this in 2008 much more vividly. This was really driven by the data. So one thing that I learned in that study about 10 years ago is that it generated a lot of hypotheses, a lot of questions that I wanted to ask further. But it also revealed to me that the charts that I had developed were very static in nature too. Things changed very quickly, particularly economic activities. New collaborations are formed, partnerships, relationships of all kinds are being formed. But visualization was very powerful for me to identify clusters, paths between firms, and understanding really the structure of economic activities. And I started to immerse myself in the field of visualization and how it could apply to understanding economic systems. And as Ben said, the the real purpose of visualization is insight, not just pretty pictures, but hopefully those pictures are also actionable and digestible and somewhat aesthetically pleasing to the decision makers that we're developing them for. So one thing that I then started digging into is that it's interesting to look at static ecosystems, and there are different techniques that we use. We use snapshots over time. We might animate them as well. But it actually turns out that ecosystems are rapidly evolving and rather complex, global in nature, rapidly evolving. And there's a diverse set of questions that you might want to ask. I really resonate with Ben's comment that the interesting problems come and the opportunities come when you talk to companies and businesses. In fact, much of this research was driven by corporate interest of understanding their broader ecosystems. So many decision makers have a myopic perspective. They might know their suppliers and partners, but nothing beyond that necessarily. Maybe they're second tier. But they might be blinded by competition that might come from somewhere else. And so they needed to have new tools to do that. Spreadsheets wouldn't do that, and simple maps might not necessarily reveal that either. And these questions could be at the firm level. What's my company doing in this overall ecosystem? In fact, people talk about the ecosystem versus the ecosystem perspective. But then they also think about the segments. Well, how are the segments related to each other? How quickly are they converging? What's the velocity of the market? What's the center of gravity, perhaps, of an industry? And then you might have something at the overall ecosystem level. Today, actually, what we're seeing is that there's competing ecosystems as well as integrating ecosystems. So when we talk about AI and healthcare, maybe those are coming really together. And so these visual tools allow us to portray the complexity of that structure and also dig deeper into it. But the key point that I want to emphasize is that we wanted to make these tools interactive because we didn't want to go back to the traditional tools, redo our analysis, and then run a set of visualizations again. So most of these tools will be interactive. Kati mentioned we have a lot of data available, and that's absolutely true. But it turns out that linking the data, despite good efforts, is still quite challenging. And I'll talk about this a little bit later on. So there's no single data source that a decision maker would go to understand the competitive landscape that they're embedded in. They have to draw on multiple data sources. And really, that's the triangulated insight that you really want to achieve. There's no real visual analytic tools that I'd seen over the years. I think there's some emerging now. Actually, there's companies being formed right around that particular emphasis as well. And one thing I want to emphasize, when we talk to our decision makers, I am absolutely perplexed at the range of visual literacy levels that they have. We ran an experiment, and it turned out that if they didn't know how to use a particular visualization, they reverted back to what they knew best, and that was spreadsheets, tables. Although that was probably the least effective method for them to solve the problems they were asked to do. So we have to take that into account when we design our solutions, and that's a very traditional HCI problem that we have, is figuring out how to maximize that technology and user visualization fit. So I talked about these data sources, and there's quite a number of them out here, and many of them you might have also seen as well and might use in your own research. So I'm going to start from left to right. And from the left, I think we have some very traditional sources that are being used, certainly in the management, finance, and strategy communities, which ranges from Thomson Reuters databases to Bloomberg. If you're looking at financial data, maybe Capital IQ. I know a lot of us mentioned patent data. USPTO data sources certainly are available, and there's many, many more, certainly. But now we're thinking, okay, these are very structured data sources. We love tabular data that's cleaned and curated, but we also realize that while those provide some insight, and they're very valuable, what we really want to do is complement them with a lot of maybe unstructured and heterogeneous data sets as well. So we've now turned to press releases, and maybe Google News and Factiva is what we use. Northern Light is a data portal as well, which gives you basically access to a lot of different data sources. But it turns out, if you want to understand innovation and science and technology, a lot of these things also happen in very small companies, maybe in entrepreneurial ventures. And not many of them are captured in these maybe curated data sets. So we have things emerging like Crunchbase and PitchBook and companies like CB Insights. It turns out that when you mesh these things together, you face a lot of challenges. Linking of data is very challenging. Finding the entities that match across them are challenging. But you can learn a lot when you do that. So in some of my studies, which I'll discuss as well, we used startup data from Crunchbase on how companies describe themselves. But we also look at their job description and technology postings that they're looking for. So we can look at what are they seeking to do in the future, perhaps, or in the near future at least. It turns out that you can also find data on their actual technology that they're using. Stackshare and BuildWith is actually revealing to us what's embedded in their website. And you can retrieve now which technologies are co-used. And this might also help people find jobs that want to find new skill sets. And so on. So I don't want to go through all these data sources. Many of these, maybe if you're not aware of, think of them. They are available. And I think that they would be wonderful to look at when you look at the trajectories of science and technology. So what I've developed in my lab, along with some colleagues across different institutions, is really a set of tools that we want to look at visual ecosystem analytics broadly. And I'll highlight some of them today. So they range from our tool called EcoSite, which really maps interactive ecosystems using any kind of data that you upload or curate directly from the web. We have a tool called Pulse, which is built on Northern Light, where we actually are curating news releases and product announcements. And then we're also looking at other things where you can actually do what-if analysis as well. So what if you were only given tabular data, but you want to construct the ecosystems that you might think might exist? So linkages between firms, for example, how would that propagate through the rest of the system? So that's taking sort of the structure and the ecosystem lens. But what we also want to know is what do companies do over time, perhaps? And so we've developed tools that looked at sequence mining of alliance activities, or more recently, what startups are doing. And one exciting study that we're doing now is looking that there's actually really a lot of data and image-based elements as well. And so we're looking at logo maps, and I'll talk about that. Okay, so I'll illustrate these tools really across these 5 projects, across the API ecosystem, venture positioning, activity sequencing. The 2 more recent ones are ecosystems of hype and then our logo maps intelligence. And each of them really fit together because they provide you a different perspective on economic activities. Okay, so let's start with the API ecosystem. It actually turns out the nature of economic activities is changing fundamentally. It used to be that alliances were the dominant form of inter-firm relationship, but it's increasingly being replaced by more flexible and fluid arrangements that are enabled by digital technologies. And APIs are certainly the ones that are creating this loose creation of economic activities. And if you're not familiar what APIs are, they're application programming interfaces. They give you access to your digital product, services, or data that you can then either recombine with other APIs to create new services and products as well. So one example that I'm giving here is, this is a screenshot now from my tool called EcoSite. What you're seeing is Google is the company at the center, and all its APIs are surrounded as a galaxy around that particular node, and they're color encoded by the main category that they're in. So we're leveraging a data source called Programmable Web on this. It's an API directory that's available. And the size of the node indicates how many times it's been reused by other APIs as well, combined into new mashups, okay? What I want to illustrate with this is that we're now not showing just a single type of node, but multiple types of nodes. In fact, in this particular data set, we also included investors. Who is investing in the digital economy as well? And so we have a multivariate, multi-partite type of network in here. We can bring that a slight level up. So in this particular view, we have called a path view. So you can expand along any of those nodes to bring its nodes in. And so I'm focusing right now on Google Maps and Salesforce, our 2 APIs that have been recombined into multiple mashups. And you see on the right when they were formed and some details on them as well. I know that we talked about triangulated perspectives. So if I have a chance, hopefully I can demo this. If not, I'll be happy to show it to you after the talk. The idea is not just to give you a network lens, but we also give you a geographic lens on this, as well as a scatter plot, because it turns out decision makers love scatter plots because they see correlations and they can put a lot of different variables in that they want to see. And then we have some more unique ones, which we call the category view, where we invert the graph itself. And I lost something here. Okay. So within that particular tool, we also allow a single node analysis that you expand. So it's the bottom-up analysis approach. We also have a top-down approach, where we say, okay, bring all the nodes in now and show me the structure. And so again, I'm showing you sort of a core of this. And this was work that I worked on with Peter Evans. At that time, he was with the Center for Global Enterprise, is now with KPMG, where we looked at the entire API ecosystem. And again, if you look at the nodes are the APIs, and the edges represent mashups, whether they are been recombined. There was a cluster that was forming around different ones. So we color encoded them by the sub-communities. And at that time, what was interesting to see is that the financial APIs were somewhat disconnected from the rest of the world. It turns out that now, if you fast forward this particular data set, financial APIs are much more embedded in this overall API ecosystem because of the increase of transactions that are happening. But we're seeing different clusters. We looked on that from a funding perspective as well. So I'm showing you sort of the view of who is making investments into the API world. And so there's a global picture and a more detailed zoomed-in version. Now, I have colleagues that tell me these are all spaghetti graphs, and I tend to agree sometimes they become very rich and dense, but in the tool itself, you can actually probe out, highlight, and mask some of these relationships so you can really see individual relationships better. Okay, so shifting away from showing you what we had data on, the structure of ecosystems that we had. The tool is, by the way, network agnostic. So I showed you the API ecosystem. We've done this for relationship in the energy space. We've looked at it for individual collaboration. Anything that you can model as a network can be ported in here. One thing that we realized is creating networks is actually quite challenging from raw data. Either you have to infer something or you have to construct networks. And so we developed a tool called Graffiti, which allows you to generate networks on the fly. Allows you also to do some what-if analysis. What if you removed nodes or edges or links? Or if you created an edge between two nodes, can the system then recommend to you why you connected them together? So one very good use case that we have for this is when we look at alliances and mergers and acquisitions of companies. So we recently heard that CVS is thinking about making an acquisition of, the company is escaping me now, a large, Aetna, thank you, sorry. CVS is buying Aetna, so that would be an edge that we could probably draw in here. And if we had this underlying data of their ecosystem, we could see what are their other linkages that might be formed based on the characteristics of those two firms, okay? So we're looking at recommendation engine of link suggestion as well. This tool actually is really powerful when you have tabular data and you want to create rapid networks, as well as when you want to explore alternative ways that these ecosystems might look like. So I'm going to shift away a little bit from network modeling itself, and we're looking at a slightly different data source. So one of the things that we were struck by is how ventures position themselves in ecosystems. And what we looked at is this rich data set called Crunchbase of looking at the textual description. And what we want to identify is how similar or different do companies describe themselves, and can we then say something about that ecosystem rather than taking an industry-specific view. And so we did this for 35 global ecosystems, and I'll show you some statistics here, anywhere from Silicon Valley, so we had a global footprint here. We looked at the number of nodes, the edges, et cetera, how large some of these components were, and what the top industry was within that particular ecosystem. But what's really interesting in here, the study that we did, so I'm showing you Silicon Valley on the left. Each node is a company. The edge is the similarity between the two companies based on the textual description. So are they using the same verbiage in describing their company? And it turns out when we do this, certain clusters emerge. It turns out analytics companies might actually call themselves or describe themselves similar to maybe a healthcare company or a fintech company. And so there are clusters of similarity and differentiation. And when we ran an analysis on what that meant for funding success, it turned out that you shouldn't be as different as everyone else, and you shouldn't be too similar to everyone else, but there's an inverted U that we found of optimal funding contingent on different ecosystem characteristics. We hope that this can help companies position themselves in the larger ecosystem, as well as understand on what are good models versus not so successful models. We also did work now, so I'm shifting away from similarity of ventures to looking at activity sequencing. And so we had work done on looking at how companies, for large companies, we looked at how they conduct alliances over time. And I'm not sure if I'll have time to switch over to the demo, but bear with me that this is interactive. As you hover over of any of these vertical slices, you see what type of relationship they formed with another company. If you rubber band over that particular selection, you can see details. And for that sub-selection or the entire data set that you have, you can do some analysis. You can find out what are the most common companies, regions, countries that a company has participated in or formed an alliance with. And then we do a very simple Markov model at the bottom, which says, if you formed a specific relationship, what's the most likely next thing that this company will do based on the historical data? So if you formed an R&D relationship, the most likely next thing that you would do is a relationship of type X or Y. It turns out that this is a highly simplified Markov model because there's many, many more states. But because the decision makers couldn't handle 7 factorial states, we had to reduce it down quite a bit. And so again, we had the decision maker in mind in understanding this complex space. We've extended this particular work to startups as well. It turns out that it's very hard to quantify the activities of startups. We've largely looked at funding, investment, acquisitions, leadership changes, and so on. And the work is still in progress there. But the idea is that we would like to mine the frequent sequences that companies and startups do, and then equate that to some sort of outcome variable as well. So can we say, is there a genome or, in this case, phenotype, because we're observing these activities, that characterizes successful or unsuccessful firms? So the last two that I will talk about, and I'll talk about rather briefly, is something called ecosystems of hype, because I think that's very relevant to understanding technology and science. So many of you are probably familiar with something called the Gartner hype cycle, and in fact, I've collected dozens of these. In fact, it's been ongoing for probably 2 decades or so. And in different areas have these hype cycles. And my idea here is that, okay, we have these hype cycles, and it says that expectations are on the y-axis, and there's some maturity level with each of these technologies. But can we now identify the companies that are actually associated with these hype technologies? And can we make sense of those ecosystems then as well? And so we've developed a tool called Pulse, which is, again, based on the Northern Light data set, where we type in the term of that technology and some variations because abbreviations, acronyms, et cetera, we had to take into account. And then we wanted to extract the companies that are co-mentioned with that technologies, and then find the companies that are co-mentioned within those documents down to a specific paragraph level. And when we do this, we use the emerging technologies. I'm showing you this for 2017. We looked at the 35 or so emerging technologies, and we again construct an ecosystem of companies that are associated with each of these technologies. And what we're seeing here on the right, it's a little faint to see, but what you'll see is different structures of different sizes. A couple interesting things that actually appear. So on the left-hand side, what you'll see is that most technologies that have 10+ years of adoption are not really found, they're not very often mentioned, and there's not a lot of companies actually associated with it. A couple of exceptions are the autonomous vehicles. It turns out most of those that are more medium term are sort of in the bulk in the middle. Many documents and a fair set of companies. On the right-hand side, when we look at the size of companies, we also see this somewhat associated with the complexity of the ecosystem. One thing that was fascinating, which I've not labeled here, is that large established companies, platform companies, operate in almost all emerging technology segments. So you'll find Amazon, Facebook, Google, and Apple at least participating or exploring different emerging technologies. So that's still work ongoing, and we're hoping to expand that. All right, so the last piece that I want to share with you today is that I know we had a speaker earlier or yesterday talking about transportation. She showed a chart like this for the transportation ecosystem. These are pervasive. You find them everywhere. Every investment company creates these. There are designers that put them on Twitter. You find them on blog articles, and also more serious companies are also doing this as well. Sorry, I did not mean seeing that the investment community is not serious. But it's across the board, you have lots of these pieces come up. But it turns out that there is no consistency on how people construct these maps. And there's really more, maybe their knowledge about a specific area, or maybe they have invested in these companies. And so our goal was to say, okay, if we curated a data set of these, and I've got about a few hundred of these that I have collected across different industries, how do we now integrate that knowledge together? Okay, and so what we did is we created a method using computer vision as identifying logos, identifying groupings of logos, proximity to labels, and then we looked at matching these logos across multiple images as well, all right? And then we created a network out of that, a knowledge graph out of that particular method. We did this within a specific industry like AI, and I'll show that to you in a second. We also looked at it from AI and education, for example. We tried to find what's the overlap between these two companies. One of the motivation here, this was really driven by industry, is that industry boundaries are still very blurry and not really well defined. And so they want to understand what are the hot pockets of innovation, who is working where, and what are the segments that are being talked in some ways on these maps. And so in AI, what we find is, again, this very large map, and if you zoom in, you'll see that there's different pockets that are being emphasized. So there's certainly analytics and health and security and finance. But what I want to drive you at here is that we identified across, these were about 16 maps on AI, 2,000 plus unique company logos. But it turns out across those 16 or so maps, there were only 700 that appeared common, which meant that a large portion of companies were unidentified by a large other set of logo maps, which means that there's this unexplored space that people are not thinking about. Okay, so a couple lessons and opportunities that I want to leave you with. I don't want to underplay the importance of understanding data. So there is a huge emphasis on data curation and linking. There is actually data half-life, in my opinion, particularly for decision makers. If I give them, if they have a strategic question, the time horizon is much longer, but you can't give them some data that might expire or is not relevant. So you have to think about this as well in designing your tools of understanding this data half-life. There's value in text and images. I know we had a speaker yesterday from BLS. I think industry classifications need to change and morph as we go along with economic activities. It turns out that I can't map a single company to a specific industry classification anymore because they operate in many, many different domains. So an opportunity here is how to use these new tools to maybe rethink how industries should be classified. Visual literacy and technology inertia on the user side is tremendous. These tools are only valuable if they're actually used by the users, and so we have to figure out how to simplify them and match them to the user. On the design and implementation piece, one thing I learned is when you design these maps of ecosystems and you use metrics that have a very deep grounding maybe in graph theory or something, you have to translate those into metrics that make sense, KPIs or some sort that make sense to the end user. And that's actually a big task and requires quite a bit of exchange with the end user. There needs to be management support in order for these to be embedded and deployed, and that is very helpful. And ultimately what you want to give them is hybrid or linked visualizations. I don't want to, absolutely I have to emphasize that evaluation is important. In fact, Ben's technique, the milk technique, is very important here. You have to have long-term studies of these being deployed, have multiple use cases, and then you can really get insights into whether those tools really are valuable or not. And all of the tools that we developed are being tested in that way. So I want to conclude with the following few thoughts. Okay, ecosystems are complex. Many of the opportunities and threats can be hidden, and I think that these visual maps can reveal some of these. ecosystem intelligence is not just a nice-have capability. I think it's a must-have when we are talking about global developments of science and technology, and as economic activities is much more global. New tools are needed, and I think visual analytics is at least one element. I think my ML colleagues certainly feel that we can bring more ML in. I believe there's going to be a blend of these things that need to happen together. Across all projects, I've learned that ecosystem structure can inform firm strategy, and firm strategy can actually inform ecosystem structure as well, how you should position yourself, what you should do in terms of collaboration. Many open research challenges, both on the technical side, but also on more the academic and theoretical side. I think one of the main points that I get back is how can visualization inform theory or create theory, and not just findings. And I think the twin success that was mentioned before, I think, of solutions and theories really need to be in there. My thinking is that visualization can be a theory, and it can actually lead to some really good insights, and then we have to figure out how to formalize them. So with that, I conclude my talk. Thank you.